Hello, everybody. So we can see here the two groups again, the inputs and the outputs. And if you recall, the linking or the mapping was that each element in the input group is mapped to an element of the output group. And the rule here was that for all the inputs that you see here, these were just shapes, or we can say polygons of different sides. For each input, the output that we got was a polygon of one side less than the input polygon that we see. So we call this map or this link between the two groups as a function, because here the input polygon is assigned exactly one output in the group 2. So with that in mind, let's come in the definition of what a function is basically. So it's a mapping, right? Mapping between two groups, and these mapping is done by a rule. So that's why you see the definition says a function is a rule or a set of rules that assigns any input to a single output. So for every input, we should have a single output. Now, there could be two inputs which have the same output, which we'll see in the example, but there can't be two outputs from a single input. We will call it some sort of mapping between two groups, but that mapping will not be called as a function. So we'll see that. Now, here you see, again, we have two groups, the input group and the output group. The input groups have words of different letters, and the output basically counts how many letters each of these words have. So if you see here, the first word cat has three letters in it, and that's why the output is three. Dog has three, so you see both these inputs give you the same output. Bird has four, shirt has five. So this function, whenever the mapping between two groups, the inputs and the outputs, is a function. And remember, when we call a mapping, there's a condition for mapping or for a map to call as a function. And the condition is a mapping between two groups can be called as a function only if for every input we have a single output. uh, that is a very important criteria for a mapping to become a function. Now, you clearly see here in this particular function, we have words as our inputs and number of letters in those words is our output. So this can be mathematically written as f of word is equals to number of letters. This is what we'll see here. So you can see that the function can be written in this form. Mathematically, this is how we write. We write f of, in the parenthesis comes the input, whatever our input is. As if you see the last example, the input were words, and then the output were the number of letters in each of these words. So if you see here, again, we have a mapping, and this mapping is again a function. Why are we calling it a function? Because like for each of the inputs that you see in the input group is linked or mapped to a single output. And if you see, the rule by which the inputs and outputs are mapped is for every input that we have. Now in here the inputs are numbers, and that's why if you see that we have a question on the right where it says which of the following represents the function that we have on the left. So you see, for inputs we have number in the parenthesis because the inputs are numbers, and for every number the output is just a number more than the input. So for 4, if we add 1 to 4, we'll get 5. In 5, if we add 1, we'll get 6. So that's why here the best which represents this function will be the first one, which shows that function of number is equals to number plus 1.